we're going to learn to graph systems of inequalities. First, to determine if a point satisfies a system, we plug in the given point into all the inequalities of the system. We simplify. If the inequalities are true, then it is a solution. If any of the inequalities are false or is false, then it is not a solution. For example, we have the point 415, and we have to determine if it is a solution to this system of inequalities. So x is 4 and y is 15. So we're going to plug in that point into both equations of the system. As you can see, we plug in the 4 in for x and the 15 in for y. When we simplify, we come down to 15 is greater than 4. That is true. We do the same thing with the second equation. Y is 15 and x is 4. And when we simplify and do the math, we get 15 is less than 36, which is also true. Since both inequalities are true, then 4, 15 is a solution to the system. When it comes to actually graphing systems of inequalities and using a graph to solve them, first step, make sure all the inequalities are in y equals mx plus b form, the slope-intercept form. Or in other words, get y by itself. The only time we get x by itself is when x is the only variable available. Step 2, we graph each inequality using a dashed line on a solid line. Remember, if it has an equal mark, we use a solid line. Otherwise, we use a dashed line. In step 3, we shade the area of the graph that contains the points that make all the inequalities true. We use a test point to make sure that we are correct. So here we're going to practice graphing this particular system. Here we have the system x is less than or equal to 5 and y is greater than or equal to negative 7. You notice both of them already have the necessary variable by itself. So we're going to skip to step 2. Since the first equation has an equal mark, we know we're going to use a solid line, and we need to shade where x is less than or equal to 5. So we graph x is less than or equal to 5 as a line. All the numbers that are less than 5 are on the left of the line. See the numbers 4, 2, negative 4, all those are less than 5. So we shade that side. Then we're going to graph our line y is greater than or equal to negative 7. Y is negative 7 here. So we draw a straight line through y is negative 7. And we're looking for all the places where y is greater than negative 7. Well, all those numbers where y is greater than negative 7 are on top. Negative 6, negative 4, 2, 6, 8, and so on. So we're going to shade in that area. Notice, when we shade those areas, there is a certain part of the graph where both colors are. In this case, right here on the upper left of where our two lines were graphed. So, since that's where the two colors overlap, we're going to take a test point. I pick 0, 0. It's my favorite test point to use if I can use it. So, since that's my test point, I'm saying x is 0 and y is 0. If I shaded this correctly, both equations of the inequality should be true. So I plug in my points. X is 0. So is 0 less than or equal to 5? Yes, it is. So it makes it true. When y is 0, is y greater than or equal to negative 7? Yes, 0 is greater than or equal to negative 7. So that is also true. Since both inequalities are true, the overlap is the solution to the system. So when we graph this finally, the only part we need to shade in is where both graphs overlap. So if you notice, when I was doing the graph, I had a space that was just green, just yellow, and a space that was both green and yellow. My final answer will only contain the space which is both green and yellow. Here we have another system that's very similar. We have x is greater than 4 and y is greater to or equal to 5. Again, in both equations, the variable is already by itself. So we're going to skip down to step 2. Since there is no equal mark for x is greater than 4, we're going to use a dashed line. So we go to where x is 4 and we draw a vertical dashed line. Y is greater than or equal to 5. Again, there's a solid mark because there's an equal mark at the bottom. So we're going to draw a solid line where y is 5, because that is our border. Now we're going to shade. X is greater than 4, we're going to shade in yellow. Since all the numbers greater than 4 for the x is higher and on the right hand side, such as x is 5, x is 6, x is 7, x is 8, we're going to shade on the right side of our borderline. For the second equation, y is greater than or equal to 5, again, we're looking for all the numbers where y is greater than 5. So the numbers that are greater than 5 are 6, 7, 8, 9, 10, and so on. They're on top of the line for y is greater than or equal to 5. So we shade above that line. Again, we must get a test point. We cannot use 0, 0 this time, but we must pick any point in the double shaded region. So I picked 6, 8. 6, 8 is right here. So again, x becomes 6, y becomes 8. So I plug them into both equations. X is greater than 4, 6 is greater than 4. That is true. Y is greater than or equal to 5, 8 is greater than or equal to 5. So that is true. Since both inequalities are true, we know this overlapping region right here in the upper right hand corner is the solution to the system. Once again, with my final answer, I only include the overlap. I do not include any of the areas that had the single colors in them. Again, when we're graphing a system, once again, we have 8x is greater than or equal to 0 and 3y is less than or equal to 0. Step 1, we need to get our equations right. For the first one, we need to get x by itself. 8 is multiplying the x, so we're going to divide, use our inverse properties. So 0 divided by 8 is 0, so x is greater than or equal to 0. 3y is less than or equal to 0. Again, we had to get y by itself. So we divide. 0 divided by 3 is 0. So y is less than or equal to 0. Since both equations have equal marks for both lines, we're going to use solid lines. X is greater than or equal to 0. Well, we go to what x is 0 and we draw a vertical line, which we have done in purple. For y is less than or equal to 0, again, we go to where y is 0 and we draw a horizontal line. Since all the numbers that are greater than 0 for x are on the right-hand side, we shade that region yellow. For y is less than or equal to 0, again, all the numbers less than 0 for y are below. -2, -4, -6, -8. So we're going to shade below the line. Our test point, well, I picked 4, -4. You could have picked 2, -2, 3, -8, whatever numbers you wanted, as long as this point is in the double shaded region. Since I picked 4, -4, I'm going to plug it into both of the original equations. I always go back to the original ones. So if 8x is greater than or equal to 0, 8 times 4 is greater than or equal to 0. 32 is greater than or equal to 0. That is true. For 3y is less than or equal to 4, I plug in -4 for y. -12 is less than or equal to 0 is true. Again, since both inequalities are true, the overlap is the correct solution right here in the bottom right. So with my final answer, I only include the shaded region where both colors overlapped. Here we're going to graph three inequalities. We have x plus y is less than or equal to 5, 6x is greater than or equal to 0, 6y is less than or equal to 0. Step 1, get all the inequalities into the right format. In the first inequality, we got to get y by itself. That means moving the x over. When we move the x over, it becomes a -x. So we get y is less than or equal to -x plus 5. Our second equation, we need to get x by itself. It's the only variable there. So to get x by itself, we divide everything by 6. And 0 divided by 6 is 0. So we get x is greater than or equal to 0. We're going to do the same thing for the last equation. 6y is less than or equal to 0. We divide everything by 6. 0 divided by 6 is 0. So we get y is less than or equal to 0. Our next step is to graph our lines. Okay? The first, second, and third inequality all have equal marks. Therefore, we are only going to use solid lines. And I am going to use solid lines and match the colors with the equations. So this first equation I'm going to do in purple. Now, we're going to start with the y-intercept, since we do have a y-intercept for this one. Okay, and our y-intercept is +5. So I'll go up here with is +5 and put my first point. My slope is a -1x. That means I go down 1 and over 1. Down 1 and over 1. Down 1 and over 1. I keep doing that till I have enough points where I can draw a straight line. My second line where x is greater than or equal to 0, I'm going to draw it in blue. Again, I go to where x is 0, which is here. And wherever x is by itself, no other variable, is always a straight line. Okay? I'm going to go ahead and shade these two before I do the third one. So, it says here y is less than or equal to -x plus 5. Well, I go back to my y-intercept. All the numbers less than 5 are below. Therefore, I want to color below the line. I'm going to do this in yellow. For x is greater than or equal to 0, again, all the numbers greater than 0 on that line are on the right of that line. Here's x is 0. All the numbers that are greater than 0 are to the right. Okay, my third line, y is less than or equal to 0. Again, get my line ready. It's burgundy, so let me pick burgundy for my line. Again, y is 0 right here in the middle. So I'm going to draw a line right in the middle, horizontal line, and that is my y is less than or equal to 0. Since I'm looking for all the numbers less than 0, I go with y is 0, and all the numbers less than 0 for y are below. So I'm going to shade below there. Now, I have to look for the region where all three colors overlap. And that is this region right here. It's not quite a square. It's a trapezoid. This is the only region where the blue, the yellow, and the green meet. So I'm going to pick a test point. In this case, I picked 4, -3. Again, you could have picked any point in this region right here. I made x4 and y -3. So I'm going to plug that into all three of my inequalities. In my first one, y is less than or equal to -x plus 5. I plug it in, the x and the y, and when I simplify, I get -3 is less than or equal to 1. That is true. For my second equation, this time I only had to plug in the x since there is no y. So 6 times 4 is greater than or equal to 0, which is true. And I do the same thing for my third equation, this time using the y. 6 times -3 is -18, which is less than or equal to 0. Since all three inequalities are true, the overlap area is the solution. And again, with the final answer, I only include the overlap area. So this little trapezoid right here, that's the only area I need to color in. We have another three inequality system. We're going to follow the same 3 steps. Step 1, the only one we have to change is the first one. So it says 4x minus 5y is greater than 20. We have to get y by itself. So the first step is to move the x over. So positive 4x becomes negative 4x. So we get negative 5y is greater than negative 4x plus 20. To get y by itself, we have to divide everything by -5. Now you must remember the rules of inequalities. Anytime you divide or multiply by a negative number, the inequality must turn around. So greater than is going to become less than. So we get y is less than -4 divided by -5x minus 4. We need to simplify the -4 over -5. That becomes just positive. So we get y is less than y is less than 4/5 x minus 4. The second inequality doesn't have to be changed, nor does the third one. So now we need to graph and shade. So again, we're going to start with the first one. And since the text is in blue, I'm going to draw the line in blue. So we start with our y-intercept, -4. So I go with y is -4 and place my dot. my slope is 4/5. That means I go up 4, 1, 2, 3, 4, and over 5. 1, 2, 3, 4, 5. Place my dot. Now I'm going to draw another dot to make sure. 1, 2, 3, 4 up, and 1, 2, 3, 4, 5 across. Then I'm going to draw my line. Again, using the same color. Okay? Since y is less than, I go to where my y-intercept again, -4. I'm looking for the numbers less than -4. And all the numbers that are less than -4 are below -4. -6, -8, -10. So I'm going to color on that side of my inequality. I use yellow. For my second graph, x is greater than or equal to 0. So once again, I'm going to use the same color as the text, so burgundy. I go with x is 0. Again, there's no y, so I'm going to draw a perfectly vertical line. Since I am looking for the numbers greater than 0, again, I go to where x is 0. All the numbers greater than 0 lie to the right. So I'm going to shade that in. As you can see, right now the only region where both colors overlap is right here at the bottom right. I need a third line. Y is less than or equal to 0. So once again, y is 0 again here in the middle. Since there's no x in my equation, I'll draw a perfectly horizontal line. And once again, I am looking for my numbers less than 0. So I'll go with y is 0. All the numbers less than 0 on the y is below. -2, -4, -6, -8. So I want to shade that area. Okay. As you can see, the only area that has all three colors forms this trapezoid on the bottom right. So I pick a test point. This time I picked 3, -4, which is right here. That's my test point. So once again, I plug it into my original equations. When I plug in my x and y's into my original equations and simplify by doing the math, the first equation I get 32 is greater than 20, which is true. My second equation I get 3 is greater than or equal to 0, which is true. And my third equation I get -4 is less than or equal to 0, which is true. Since all three are true, then I know that point satisfies the system. So that's the area of the system that should be colored in with all three colors. So I know that I am correct. Once again, with my final graph, I only include the area with all three colors. So I do not include the areas where there's only one or two of the colors. In this example, we have only two equations, but neither one is in the right format, so we need to fix them. With the first one, again, to get 10y by itself, we need to move the 20x. It's positive, so it becomes negative. So we get 10y is greater than or equal to negative 20x plus 35. We got to get y by itself, so we have to divide everything by 10. So we get y is greater than or equal to negative 20 divided by 10x plus 35 divided by 10. Now for the sake of graphing, I'm going to divide and turn everything into decimals so that I can easily graph this. So I have y is greater than or equal to negative 2x plus 3.5. Second equation, we're going to do the exact same thing. Get y by itself. So first step is move the 4x, making it negative. Then divide everything by negative 8 to get y by itself. Remember, we're dividing by a negative number, so we have to switch the inequality around. Greater than becomes less than. Negative 4 divided by negative 8, and 48 divided by negative 8. When we divide and simplify, we get y is less than 1/2 x minus 6. Again, to graph, we're going to start with this first equation in blue. Y-intercept is 3.5. Please notice the graph. The graphs are not going up in steps of 1, but a half. So we have a half, then 1, 1.5, 2, 2.5, 3, 3.5, 4. So 3.5 will be right here. Then I got to go down 2 and over 1. Okay? Down 2, 1, 2, and over 1. Again, I'm taking bigger than normal steps because the graph is going by halves and not one. So it takes 2 halves to make a whole. So again, go down 2, 1, 2, over 1. Down 2, over 1. Down 2, over 1. So that would give me my first line. And again, I've got to color in my shading. Since it says greater than, all the numbers greater than 3.5 are above. So I need to color above this line. And I'm going to stretch it out a bit so I don't mess up my coloring. Okay. My second equation I'm going to do in red. And again, y-intercept is negative 6. And again, I got to go up 1 and over 2. Up 1, over 2. Up 1, over 2. And then I draw my line in red. To shade, again, it says y is less than. So all the numbers less than y are below. So I got color below this red line. Oops, wrong color. I need red. Here we go. Let me erase that. Right. As you can see, the only part of this graph where both colors overlap is this tiny section here, down on the right hand side. So I have to do a test point. I use 6, -4, which is right here, right on the edge of my graph. So x is 6, y is -4. So I'm going to plug that into all three equations. In the first equation, when I plug it in, I get 20 times 6 plus 10 times a -4 is greater than or equal to 35. I do the math, and once I simplify, I get 80 is greater than or equal to 35, which is true. For my second equation, again, 4 times 6 minus 8 times a -4 is greater than 48. So I get 24 minus a -32 is greater than 48. 56 is greater than 48, which is true. Since both inequalities turn out to be true, I know that that point is in the correct region. So once again, in my final graph, I only include overlap right there. You now have enough knowledge to complete your assignment on mathexcelforschool.com, Solving Systems of Inequalities. Complete problems 1 through 16. We will do 17 through 22 tomorrow when we talk about how to solve real-life application problems involving systems of inequalities. After you have finished your assignment, you may work on makeup work and work quietly on your computer.